Look at a map of the Earth. I mean, you see continents, you see oceans, right?
Right. Yeah.
And when you look out your window at a mountain range, there is this immense, almost subconscious comfort in permanence.
Oh, absolutely. You think that mountain has always been there.
Exactly. And that the ocean has always looked exactly like that. But what if I told you that map is just a snapshot? Like a snapshot of a planet being slowly crushed in a cosmic vice grip.
It's totally counterintuitive to how we're taught to view the world, really.
Yeah.
Because we build our entire understanding of reality,
Yeah.
our history, our geology, our science, on this foundational belief that the cosmic architecture around us is static.
Like it doesn't change.
Right. We like to think the solar system is just a reliable clockwork mechanism.
Yeah.
Like it was wound up billions of years ago and now just predictably ticks away, totally unchanging.
But today, for you, our resident learner listening in, we are jumping into a deep dive that completely shatters that clockwork model.
It really does.
We have our hands on this fascinating stack of translated notes detailing a truly radical theory. And this material merges ancient texts and allegories with modern astrophysics.
It's a really unique blend.
It is. It proposes that the ground beneath your feet and literally the entire solar system is not a fixed structure at all.
No, not even slightly.
So our mission today is to unpack the core premise of these notes. It's a concept known as the mechanical egg or a pulsating universe.
And the sources offer this remarkable synthesis. What we're doing today is looking at how these translated notes take ancient Puranic allegories and frame them as a strict mathematical model.
A model of planetary expansion and contraction, right?
Exactly. It is essentially a story of how cosmic geography, specifically our changing distance from the sun, dictates Earth's physical reality over these massive epochs of time.
Okay, let's unpack this. Because to understand how the Earth itself physically transforms, we first need to understand the cosmic engine that's supposedly driving these massive shifts.
Right, the engine.
The sources introduce this idea of the solar system functioning as a mechanical egg, or in the original Sanskrit terms from the texts, the Brahmandiya Anda.
The defining characteristic of this Brahmandiya Anda, this mechanical egg, is that it's alive, well, in a mechanical sense anyway.
Right.
The distances between the planets and the sun are not permanent. The sources propose an engine driven by massive cyclic fluctuations in gravitational and electromagnetic forces.
So the whole thing breathes.
The entire solar system pulses, yes.
So instead of a fixed orrery of the solar system, like the kind spinning on a desk, we should picture a beating heart.
Or maybe a cosmic accordion.
Yeah, like a giant pair of lungs taking a massive breath in, expanding all the planets outward, and then slowly exhaling, contracting everything back in.
That's a great way to visualize it.
And over these massive cosmic epochs, which the texts call Yugas, planets are pushed incredibly far out into deep space, and then much later they're pulled tightly back in, close to the sun. But wait, I'm struggling with this right out of the gate. If the Earth is constantly shifting its distance from the sun over these massive epochs, wouldn't the planet just tear itself apart?
You would think so.
I mean, a planet isn't a rubber ball. How does a planet survive that kind of orbital shift intact?
Well, that's the exact hurdle modern astrophysics would raise. And the sources address it by actually altering our assumptions about baseline physics.
Wait, really?
Yeah. What's fascinating here is that the text doesn't treat physical laws as absolute constants independent of environment.
Okay, so the rules change.
Exactly. In this model, shifting distances from the sun aren't just astronomical trivia about our orbit. They fundamentally alter the baseline physical reality of the planet itself.
Mind-blowing.
As Earth is pushed outward, the gravitational pull exerted on the planet by the sun drastically decreases. The ambient electromagnetic pressure drops.
So it's literally under less stress.
The tidal forces ease up. The physical state of the planet, its density, its structural integrity, relaxes and expands in tandem with the orbit.
So the environment dictates the physics. The Earth, at its furthest point from the sun, is going to operate under completely different rules than the Earth at its closest point.
The rules adapt to the proximity of the star. And that changing proximity sets the stage for the different yugas or epochs mentioned in the sources.
Okay, that makes sense.
The Earth doesn't tear itself apart because the forces acting upon it change gradually over millions of years, allowing the planet's geology and atmosphere to reach a new equilibrium at every stage of the pulse.
Wow. Okay, so if the physics fundamentally change depending on where we are in the pulse, what does the extreme end of that spectrum actually look like?
The maximum expansion.
Right. Let's travel to the point of maximum expansion to see what Earth looked like at its furthest possible point from the sun. The sources call this era the Satya Yuga.
During Satyuga, you were looking at an Earth experiencing remarkably low cosmic pressure and just a fraction of the gravitational pull it experiences today.
Just floating out there.
The planet is in a state of maximum relaxation. Because the pressure is so low, the physical land masses of Earth are vast and sprawling.
Right. Because nothing is squishing them.
Exactly. The crust isn't being compressed, so the land just expands outward.
The text paints a picture of this era that feels almost unrecognizable. I mean, it's an expansive, giant world. But the wildest detail to me isn't the land itself, it's the water.
Oh, the water situation is fascinating.
Right. The sources explicitly state that during this time of maximum expansion, there are no massive oceans like we have today. None.
Consider how defining our oceans are to our modern understanding of the blue marble.
Yeah, 70% of the planet.
But in this low-pressure, distant orbit of Satyuga, the mechanics of water distribution change completely.
Where does it all go?
The water is either locked deep inside the Earth's expanding crust, sequestered in subterranean caverns that have opened up due to the low pressure, or
it's frozen.
yes, or it is frozen solid at the poles because we are so far from the sun.
So the only open water that exists on the surface comes in the form of rare, small ponds hidden deep within vast forests.
It sounds incredibly arid.
But also completely serene, just endless sprawling land masses bathed in a distant, cooler sunlight.
It really forces you to completely reset how you visualize planetary geology. Imagine this vast world where the density of every object feels fundamentally different to how we experience it today.
Well, here's where it gets really interesting, though. Because of this low-gravity environment, the Puranas describe something called flying mountains.
Which sounds completely absurd at first glance.
Totally. I mean, if you just read the phrase flying mountains in an ancient text, your brain immediately goes to mythological fantasy, right? Like magic.
Naturally.
But the notes we are reviewing transform this into a strict physics equation.
It's just the physics of buoyancy and mass in a diminished gravitational field.
Yes. According to the text, because the Earth was at its furthest point from the sun, and the overall ambient gravity was so incredibly low, massive boulders and colossal rocks were remarkably light.
The structural integrity of a mountain behaves differently when it isn't being crushed by the intense gravitational and electromagnetic pressure we experience today.
Right. The rocks were so light they could literally float or be easily lifted into the air.
A mountain in the Satyuga isn't an immovable, crushing weight, pinning the crust down. Because the planet isn't being compressed by solar tidal forces, the crust is highly porous and less dense.
Like a pumice stone or something.
Exactly. In a low-gravity environment, the atmospheric density relative to the rock density shifts. A massive boulder could easily be dislodged, tumbling, or even hovering slightly.
That's crazy to picture.
It's akin to how astronauts can casually toss heavy equipment around on the moon, but scaled up to a planetary level.
It's like being on a completely different planet. But, you know, if a low-gravity environment keeps the land expanded and the water trapped inside the Earth, what's the tipping point that eventually forces it out?
Because it can't stay there forever.
Right. The Earth can't stay in expansion forever.
The cosmic lung can only take in so much air before it has to exhale.
It has to breathe out.
The momentum of the expansion eventually peaks, and the immense gravitational anchor of the sun begins to slowly reel the planets back in.
Earth starts its incredibly slow journey back toward the sun, and according to the sources, this triggers massive internal and external changes.
It's a huge transitional phase.
This transition happens at the end of the Satyuga, a period the sources call the Sandhyamas, and it marks the beginning of the Treta Yuga.
And this is where things get active.
Yeah. As Earth's position shifts and it starts getting closer to the sun, all that water that was previously trapped deep inside the Earth begins to emerge.
It gets pushed out.
It pushes its way to the surface, forming the very first rivers and the beginnings of oceans. I was reading this and I just imagined the Earth as a giant cosmic sponge being slowly squeezed by invisible hands, forcing the water out from the inside.
That sponge analogy is a great way to visualize the mechanics, actually. Though if we look closely at the astrophysics proposed here, the invisible hands are doing a lot of complex work.
What are the hands in this scenario?
The hands are the increasing gravitational and tidal forces from the sun. As the Earth moves closer, solar gravity pulls unequally on the near and far sides of the planet, literally kneading the crust.
Oh, wow. Kneading it like dough.
Yes, the internal temperature rises, the subterranean caverns compress, and the water is physically forced upward through the rock.
But the water isn't the only thing that emerges during the Treta Yuga. The sources note something that totally blew my mind.
About the seasons, right?
Yes, they state that the six-season cycle, which they call the Ritu Chakra, is born during this exact transitional period,
Oh, yeah.
which means seasons did not exist prior to this orbital shift.
It's wild to think about.
We treat seasons as a planetary constant. Like, of course the Earth has seasons.
We assume permanence. But if we connect this to the bigger picture of the mechanical egg, the birth of seasons makes perfect sense.
How so?
Well, climate and weather patterns are a direct consequence of a planet's proximity to its star, the thickness of its atmosphere, and its axial tilt.
So in the extreme expansion of Satyuga, it was just one static climate across the whole planet.
Effectively, yes. The distance was too great and the atmosphere too thin and expanded to create the dramatic thermal variances that drive our modern weather fronts.
It was just perfectly stable.
But as Earth is pulled closer during the Treta Yuga, the angle of solar radiation becomes more intense and more variable across the planet's surface.
So the heat gets turned up.
The heat gets turned up, and it interacts with the newly emerged surface water. Those early rivers and nascent oceans begin to evaporate.
Creating clouds and rain.
Exactly. You introduce water vapor into a compressing atmosphere, and suddenly you have complex weather systems. You are moving from a static, dry, low-gravity rock to a dynamic, evolving ecosystem with rain cycles, prevailing winds, and shifting temperatures.
It's literally waking up.
The Ritu Chakra is just the ancient terminology for a planet achieving a close enough orbit to experience solar-driven climate cycles.
Okay, so the sponge is being squeezed, the water is flowing, the winds are picking up. Which brings us to the inevitable climax of this contraction.
The crunch.
Right. If Treta Yuga is the gentle squeezing of the sponge, the next epoch must be the ultimate high-pressure crunch. This happens as Earth reaches its closest possible proximity to the Sun in the cycle.
And this phase is what the sources identify as the kaliyuga.
The Earth is now being subjected to extreme gravitational pull, immense tidal forces, and severe electromagnetic pressure because it is practically hugging the Sun compared to where it used to be.
The physical toll on the planet is incredibly violent.
Tectonic plates are crashing into each other, and the actual landmass of the Earth shrinks as the crust is compressed. And this leads to a massive twist in the notes regarding modern geology, specifically the interpretation of Pangaea.
This supercontinent.
I am still completely stuck on this concept. I mean, in school, we're all taught about Pangaea as a one-time origin story, right?
Right, the singular massive continent.
Hundreds of millions of years ago, all the continents were squished together and then they drifted apart to where they are today. But this source flips the script entirely.
It changes the timeline.
It says Pangaea is not a one-time event. It's a recurring cyclic event. At the peak contraction of every single kaliyuga, the cosmic pressure crushes all the landmasses together into a single, small supercontinent.
It's a fascinating paradigm shift.
So what does this all mean for how we view geology? It takes this unique historical miracle and turns it into a routine planetary pileup.
It raises an incredibly important question about how we interpret the geological data beneath our feet.
Yeah, because the rocks don't lie, but maybe our timeline does.
Exactly. Modern science looks at the fault lines and the tectonic plates and sees indisputable evidence that they were all once pushed together.
Right.
But the standard conclusion drawn from that evidence assumes a linear timeline that it happened once in the distant past, and we've been expanding outward ever since.
A straight line from a clustered past to a spread-out future.
But the mechanical egg model suggests a circle. The mechanics of the tidal and electromagnetic forces at this close proximity act exactly like a planetary vice grip.
Just squeezing the Earth.
It is physically forcing the continents to collide and fuse. As the Earth breathes out and moves away from the Sun in the next cycle, the pressure releases, and the continents drift apart.
And then as it's pulled back in.
They are crushed back together.
Under this theory, Pangaea isn't an origin story. It is simply the recurring geological footprint of the Kali-Yuga contraction phase.
A planetary vice grip crushing the land masses together, which sounds terrifying just from a geological standpoint, but then we have to factor the water back into the equation.
Yeah, the water makes it much worse.
Right. We have a shrinking landmass being compressed into Pangaea, and we have all that water that had previously emerged from inside the Earth during the Treta Yuga. What happens when you combine shrinking land with rising temperatures?
You inevitably arrive at a mathematical catastrophe. Exactly. I mean, the math is inescapable. Because the Earth is now so close to the Sun in Kali Yuga, its core heats up immensely.
And the ice at the poles.
The polar ice, which held so much of the world's water during the expanding phases, melts rapidly. And because of the extreme compression of the crust, even more subterranean water is forcefully expelled to the
That's
surface.
a perfect storm.
It's like sitting in a bathtub where the walls are violently closing in on you, but someone just turned the faucet on full blast.
The bathtub analogy perfectly highlights the two colliding variables. The volume of the container, the surface area of the Earth's crust, is shrinking under cosmic pressure.
While the volume of the liquid, the surface water, is exponentially increasing.
And the result of that equation is a massive global deluge.
The texts reference this as the Mahabharata, which translates to the Great Flood, or what countless cultures refer to as Noah's Flood, the Deluge of Gilgamesh, or Manu's Flood.
It's a universal human memory.
In this framework, it isn't just a heavy rainstorm. It is the physical displacement of oceans over a shrinking landmass. Coastal areas and massive stretches of land drown completely.
Everything gets swallowed up.
And here is the absolute kicker from the source. This specific contraction process, this bathtub with the walls closing in, is the exact reason why Earth is currently 71% water and only 29% land.
It is a profound synthesis of ancient myth and proposed physics. I mean, we have countless allegories across human cultures that describe a world-ending deluge.
Right, everybody has a flood story.
Traditionally, historians interpret these as localized river floods that were exaggerated over generations, or simply as moral fables meant to teach a lesson.
Just stories.
But if you apply the astrophysical framework of the mechanical egg, the Great Flood isn't a fable. It's an irrefutable scientific and mathematical principle of a contracting planet.
The math simply demands a flood. If the surface area shrinks and the ice melts, the water has nowhere to go but over the land.
What the ancient sages explained through metaphor and story, they were, according to this text, actually describing the extreme end-stage mechanics of a close proximity orbit.
So that ratio isn't an accident.
Not at all.
Yeah.
The 71 to 29 water-to-land ratio we see today isn't a random coincidence of planetary formation. It is just the current high water mark of this kaliyuga contraction.
It really makes you look at a map of the world differently. You aren't just looking at continents, you're looking at the survivors of a cosmic squeeze.
A snapshot of the crunch.
So, to summarize this incredible journey, the notes have taken us on the mechanical egg model, starts us with a massive low-gravity Earth floating far out in deep space during the Satya Yuga.
A world with vast lands, hidden subterranean ponds, and literal flying mountains made possible by low atmospheric pressure.
Then, as the cosmic lung exhales, we move through the Treta Yuga, where the planetary sponge is squeezed, bringing forth the first oceans and creating the complex weather systems of the six-season climate cycle.
The birth of the seasons.
Finally, we end up in the Kaliyuga, where Earth is pulled violently close to the sun, crushing the continents back into a recurring Pangea, melting the poles and drowning the world in a mathematically inevitable great flood.
Leaving us with the watery blue marble we inhabit today.
It is a stunning, comprehensive model of a dynamic, living solar system. It attempts to answer every major geological and climatic mystery through one single, elegant mechanism.
It really is elegant. But there is one final lingering thread drawn directly from the end of the source material that we absolutely need to consider.
The cliffhanger at the end of the notes.
Yeah. If this cyclic rule of expansion and contraction, this mechanical egg, is a universal law of our solar system that applies to Earth, what about the rest of our planetary neighbors?
Oh, right.
The text invites the reader to look up at the night sky and wonder, are massive gas giants like Jupiter and Saturn, or our rocky neighbors like Venus and Mars, currently shrinking under this exact same cosmic law?
I mean, if the entire system is a pulsing lung and we're all attached to the same gravitational engine of the sun, they have to be, right?
You would certainly think so.
They must be undergoing their own versions of a Kali-Yuga crunch.
That is the necessary implication of the theory. And the next logical step, which the source explicitly hints at, is looking at modern space exploration.
Like our rovers and satellites.
Exactly. How might the raw incoming data from NASA and other international space agencies ultimately align with these ancient mathematical calculations?
What are we actually seeing up there?
Right. When we send probes to Mars and discover evidence of ancient oceans and shifting tectonic fault lines, are we just seeing the remnants of its own expanded Treta Yuga?
Wow.
Are our satellites currently recording the slow, agonizing contraction of our neighboring planets without us even realizing what we're measuring?
Wow. I started this deep dive talking about that globe on the desk or that mountain outside the window and how comforting their permanence feels.
It is a comforting thought.
But after walking through the mechanics of this framework, I don't think I can ever look at them the same way again. That mountain isn't just a static rock. It's a previously floating boulder just waiting for gravity to let go again.
Just waiting for the next cycle.
And that ocean isn't a permanent fixture. It's just the high tide of a cosmic breath. It really makes you realize how entirely dependent our physical reality is on where we happen to be standing in the cosmic cycle.
You're just riding the pulse of the engine.
Riding the pulse. I love that. Well, that is all the time we have for today's exploration. Thank you for joining us on this deep dive into the mechanical egg. Keep questioning the ground beneath your feet, and we'll catch you on the next one.